This video is going to be on conductors versus insulators. Alright, so let's go into more detail about a conductor and an insulator. Okay, so the first question is going to be, how are they different? Like, I want you to be able to differentiate or tell a difference between a conductor and an insulator. And basically, a conductor is any object that allows electrons to flow easily. Okay? And then an insulator is opposite of that. Oh, wait, before I even get onto an insulator, let me go ahead and talk about a conductor. Basically, it is any object that allows electricity to flow easily. Some ideas or some examples would be metals. Any kind of metal, mostly. Mostly any kind of metal. Copper, iron, those kinds of metals. Okay, and then an insulator, I'm just going to give it to you, is any object that does not allow electricity to flow easily. And some examples would be non-metals like rubber and plastic. Okay, wood, cloth. Those are examples of things that don't conduct electricity very easily. And when I say conduct, I mean specifically allowing electricity to flow. If you are not being a very good conductor, that means you're weakening the process. You're not allowing things to flow. Okay? An insulator does not allow electrons or electricity to flow easy. Like, they still flow, it's just not very easy. And if you have very slow current movement, you saw in the electrical unit when the current was really slow, you barely saw anything. I don't even think you saw any power. But when it's flowing really quick, you see power. Okay? On with the next. So now the next question is, what happens when you put a charged object and you touch any one of these? Like, what happens when a charged object touches an insulator or a conductor? And when I say charged, I think I gave you guys an example in class where I took a balloon and I rubbed the balloon on my body, and then I took it and I stuck it up to the wall, and then it stuck to the wall. What I did when I rubbed it, when I was actually rubbing it on myself, I was charging it up. Okay, so that means I was taking some of the electrons, or I was adding some of the electrons on the balloon. And then the balloon had an overall, whatever type of charge it had, and it was able to stick to the wall. So what happens when you take a charged object like that? Or another good example is when you're, in your house and you're dragging your feet across the carpet and you touch a doorknob, you get a shock. Okay, what actually happens? Why do you get that shock? What happens when you touch an insulator? So I can drag my feet all day and then I can go to my wooden file cabinet and touch it and I won't receive any shock. Why is that? So here we go. This is a little picture that I've drawn. And this is basically because electrons are going to transfer to an insulator, but they're not going to be able to transfer through it. Okay? I don't know why this thing is writing so slow. So here's a picture of what I just said. Electron. So right here I have a finger, a very charged finger, and it goes in to touch a rubber object. And when I say charge, that means maybe like I was rubbing my finger on my shirt and I charged it up. So now the tip of my finger has a buildup of electrons. And these electrons don't just come from nowhere. What happens when you rub your finger across your shirt, you are actually taking electrons off of your shirt and putting them on your finger, which is why you have a buildup of extra charge on your finger. So when you touch this rubber object, what happens? Nothing. They can go through it, they can go to it. So now these electrons, this buildup ends up going here. But because insulators don't allow electrons to flow easily, they don't disperse very quickly. So then you don't receive or see any shock. Okay? So now a conductor is different because when you touch an electron, you immediately transfer them from your finger to the conductor. And that in that immediate transfer, that quick transfer, you feel a shock. And that shock is because you have electrons flowing. And when you have electron flow, you have electricity. Okay? So that's why when you touch a conductor, they are able to distribute. You see right here, those electrons that were on my finger are now in here and they have evenly distributed. All right. Why did they evenly distribute? That is a good question. Let me just go ahead and go over that real quick. So let's say let's look at this in a bigger picture. If I could just zoom in and I have all my electrons and they're evenly distributing. Why are they evenly distributing? How come they look like that and not like this, for instance? I got this and how come in a conductor they look like this and they don't look like that? Okay, well, think about it. These right here are electrons, right? Electrons, and they're all negatively charged. And if you have a whole bunch of same charges together, do you think the same charges want to sit next to each other? No. They want to spread out as much as possible. And so that is why they look like they're evenly distributing, because they're actually spreading out as far as possible. Okay, this is why they're not all huddled up together. If there was no issue with them being, the same charge, like let's say they were pluses and minuses, then they would clump more together. But the fact that they're all the same charge, they're going to evenly distribute, and that's what you're going to end up seeing. As I was saying, basically, this is what happens when you touch a conductor. The electrons transfer through you quickly, which is why you feel the shock. You feel the shock because electrons are moving, which is electricity. That actually brings me to this next question. What is static electricity? Static actually means stationary, okay? And then obviously electricity means the flow of electrons. So when you have static flow of electrons, that means you have electrons that are not flowing. They're not going anywhere. That is static electricity. So then the next question is, why do charges move when touched by a conductor? Well, if you go back to my finger, you have a buildup of charges. And they don't want to sit on your finger like that forever. When you touch a conductor, the conductor kind of acts like a bridge, okay? And though it's a bridge for all those electrons to be able to flow and evenly distribute, because that's exactly what they want to do. They want to flow and distribute evenly. Get away. Just think about it. Like, act like that those electrons are you trapped in a car with a bunch of stinky people. Okay? So the moment you are able to open that door, what are you going to do? You're going to spread out as far as possible as you can from those people. You're going to move quickly to get out, and you're going to spread out as far as possible. So that's basically what a conductor insulator is, okay?